Hi guys, happy Tuesday. You ready for a lab? This Tuesday lab might become a thing. Today it's the triangle inequality theorem. I'm going to show you how it works as it regards to the sides of a triangle. So look over my shoulder here and I'll show you how it's done. And after that we're going to look at a little program online that I found which you can play around too, and it'll show you kind of how that works in real life. So, come on, let's go. Okay, guys, so now you're looking over my shoulder, and what I have set up here is a triangle. Now, to make it easier, I've colored the three different sides. So, our green side is a set length of 8 inches, and it doesn't move, right? It's going to be our base. This red length is a set length of 5 inches, but it can pivot. And our blue is right now 6 inches, but it can pivot and it can change its length. So we're starting off with a very simple triangle. It's 5 inches on one side, 6 inches on the other, and 8 inches across the bottom. So talking about the triangle inequality theorem. Now remember, before we left on vacation, it was all about the angles, right? And we know that each angle adds up to 180 degrees. But now we're going to talk about the length of the sides and how they relate to each other. And the triangle inequality theorem is a really, really basic idea. It just says if you take the longest side, the two short sides have to add up to more than this length, which makes sense, right? For instance, here we have a length of 5, and here we have a length of 6. Put that together, and that's a length of 11. And 11 is greater than 8, right? So why does that work? Well, let's make this side a length of 4. Well, we can bring this down to match, right? So now we can have a triangle of length 5 and length 4 with a base of length 8. And 5 plus 4 is 9, and 9 is greater than 8. But can we get 8 on one side and 8 on the other? If we had 5, 6, 7, 8, so could we have a length of 5 on one side and 3 on the other? Well, we can't, and I'll show you why. As the closer you get to 3 on this blue side, the smaller our triangle gets, right? And if you get all the way down to a length of 3 and a length of 5, well, that's the same line as the bottom, right? So that is the length of 8. So the first part of the triangle inequality theorem is if you're looking for one side and you have two other sides that are given, it has to be greater. Not much greater, right? Like this is like almost 3.2, right? But that's enough to give you a triangle because it's just enough that it's 8.2 altogether, which is greater than 8, which is just enough to give you a triangle. And you can just keep on building a triangle like this. You may ask yourself, well, what happens if two sides are the same length? Does it still work? And it does, because if you pull this out to 8 inches, so you have 8 inches on the blue side, 8 inches on the green side, we can still have 5 inches on the red, which gives us an isosceles triangle. So this way, either one of these could be the longest side, right? So either way, if you take the blue side as the longest, the other two sides are 8 plus 5, right? Which is, what, 13? So the other two sides are 13. But if we take this one as the longest side, then these other two are going to be 13. So why is this such a big deal? Well, what if instead of, say, 4 and 5, which is 9, which is greater than 8, or 3 and 5, which is greater than 8, what if we had... We know it can't be 3, right? Because if you bring the two together, it'll become that line. And we don't want a line, we want a triangle. So what if our shortest side was 2? In other words, can we make a triangle out of 3 lengths of 8, 5, and 2? And the answer is no, we can't. Because as much as we can try, we can't get these two lines to meet. So in order for the opposite two sides to meet, these two together have to add up to be longer than this. So you'd have to be greater than 3. And as you can see, it doesn't matter. But notice, once you get past this point, right? Once you get past the isosceles, where we have a length of 8 on both sides, if we had a length of 9, now this becomes our longest side. In order for the triangle inequality theorem to work, the green side and the red side added together have to be greater than the blue side. And of course it does. So let's try something a little different. Let's take this 5-inch, make it a 3-inch. Boop. So now we only have 3 inches on this side. So a 5-inch and a 3-inch can't go together because, well, that just adds up to 8, which is the same as the third side. So now this side has to be greater than 5. And other than that, it works the exact same way, right? Do we have a side of 7? Well, yeah, because that'll line up right there. A side of 8. Now we're at the isosceles point. What if we're greater than isosceles? Well, what if we make a long triangle out of this? What if we have, say, 11 inches over here, excuse me, and 3 inches over here? Well, that wouldn't work, right? Because 3 plus 8 is 11. So we can't have 11 inches over on this side. It would have to be less than 11. Not a lot less than 11, but just enough to make that work, right? What about 10 and a half? Yeah, we could go 10 and a half. See, 10 and a half matches up here. So what if we had 9? Would that work? Well, it wouldn't work here, but it would match up there. So as long as you discover what your longest side is, add up the other two sides. The other two sides have to be greater than that third side. And that's the triangle inequality theorem. Now the other side of that is, what if you don't know what this is? What if this is just a blank side? And you say, well, how long and how short can this be? Well, the way you do that is you go all the way down to the smallest side there. So you can see if it's 5 and 3, that's equal to the longest side, which is 8. So we know that this has to be greater than 5 in order to make that a triangle. So this side can be greater than 5, but it has to be less than 8 plus 3 is 11, so it has to be less than 11. So if we're looking for a third side saying, well, what can this be? How many triangles can we make out of this? Well, we can make any triangle as long as this side is less than 11, but greater than 5. And that is the other useful thing about the triangle inequality theorem, is that not only can you determine if you can make a triangle out of two short sides, knowing what the long side is, but if you know what two of the lengths are, but not what the angles are, you can figure out if you can make a triangle out of that third side or not. What's the smallest it can be, and what's the largest it can be. And the largest it can be are these. The largest it can be is less than these two sides added together. And the smallest it can be is the length of these two sides subtracted from each other. See here? So 5, greater than 5 is our shortest side. Less than 11 is our longest side. And if we know that, we could build any triangle we want to. And that, in a nutshell, is the triangle inequality theorem.